Hello, this is my Lab 2 lines of charge for Physics 2212. This report has three main parts and a conclusion. We will start with an introduction to show the purpose and objectives and also some of the experimental results. Then we'll look at the setup of the lab and then we'll look at the model and finally the conclusion. The purpose of this lab was to follow the lab one, but add some more things that we learned in class. And well, to accomplish this, instead of treating the tape as a single point charge, we will be dividing the U-tape into segments, and then we will treat each segment as a line charge in order to get an accurate estimate uh, of the charge and general electric force. And well, the results tell us that the electric force of 100 segments, it's 3.71 times 10 to the negative 8 power coulombs, and the electric force also is equal to the gravitational force. That is something that we got from lab 1. So here you can see a few of the concepts that we will be working with. We have, of course, gravitational force, which is something that we've been working with since physics 1, and Coulomb's law, the also the electric static equilibrium and superposition, which well, the principle, just to refresh, is the idea of using different segments of point charges in order to more accurately model the electric field and then just having the summation of all of them. And well, we also have the second and third Newton's law. So some of the assumptions we made in order to perform this lab were that air resistance could be neglected. Well, also that each segment was gonna be considered a point charge, which well might not be the case, but that's the way we did it in order for it to work. Also that the U-tape could be divided into several segments with charge evenly distributed on the tape. We don't know if this is the case, but that's the way we worked with. And also that all of the charges would sum up to the total charge of the U-tape. So it is important to identify the results of lab 1 and overall just refresh on it in order to perform this following lab. Well, this lab gave us the mass of the U-tape to be 0.23032 meters and the mass of the U-tape to be 0.002032 kilograms, and the distance between the tapes to be 0.0406 meters squared, and the magnitude of the gravitational force to be 0.0019 newtons, and the overall charge of the tape, taking it in a different way than we're gonna be doing so, to be 2.27 times 10 to the negative 8. As we mentioned before, we're gonna be using a model to show what's happening in this experiment. And well, this model takes into account different constants that are also used for lab 1. And well, the different forces, force of gravity, electric force, and it has a calculation to calculate the charge. It is important for this part to identify first that we have a nested for loop, which just help us work with the concept of superposition. The code iterates through each segment and then adds the electric fields, individual electric fields together to get a net electric field for the tape. And then this code makes arrows, as you can see, to show the electric and gravitational fields, and also at the end it prints the magnitude of both of these values. So here we have the two different images for lab 1, the results of lab 1 and the result of lab 2. You can see that the charges are not equal, nor do they look the same. And well, the reason of this is because we calculate them with different methods. We calculate the charge with different methods. And also, as you can see, this image looks quite different, and that is because we calculated with 100 segments. So the lines of the charge look as one object instead of individual lines. So to answer question number 1, what would have happened will be that we would get different values. And also, well, question 2, the estimates differ because they were calculated through different methods and different formulas and calculations. Also, for lab 1, we only took into well, the calculation and the method used only takes into account the y direction, while in this case we consider the entire xy plane. Therefore, that indicates that the methods used in lab 2 would give us a closer approach to what happens in real life. And well, some of the errors in this lab could include the lack of consistent length of our tape that we used, and also that the tape had to had to be handled, so that might change some of the charges. And well, to fix this would be creating a neutrally charged two prolonged takeholder to contact A with a less surface area and allow it to fit easily and without touching it so much.